You see that?
Yeah.
So we did. What did we do in Molecular? So in Molecular we did this. Did we do both of them in Molecular?
We did the first one because we have to do the second one in class.
Okay. This we were going to do now.
Yeah.
Okay. So this is isoelastic. Okay, so the problem had price was equal to k cubed minus beta. There's a demand curve. The cost of firm I C I Q I plus C I naught plus C I 1 Q So how do we go about solving for the Cornell outcome in this setup? What's the first thing we're going to write down?
The profit function.
Yep. So what are profits going to be? Anyone else? Okay, well, it's always the same. It's always price times quantity. So price here is going to be k q to minus beta times the quantity produced by thermi minus the total cost for thermi, okay, which were this expression here. Okay, so Ci naught minus Ci1 Qi. So that's what profits look like. So next thing to do is to maximize profits, right? So the first order condition is we're looking for when the derivative of profits, thermi's profits with respect to thermi's quantity, dqi. Well, what's this derivative going to be? So we're going to get a k in the front, okay, which is the constant. And then we've got something times something, so we use the standard product rule to differentiate that. Okay, so what's the derivative of capital Q with respect to little q? What's the definition of capital Q?
Twice two of the quantities, isn't it? Q.
Yeah, it's the sum of all of the quantities. Okay, so Q, capital Q is going to be Q1 plus Q2 plus all the way up to Qn, right? So for any I, if I is 1 to, for any I in 1 to n, the derivative of big Q with respect to Qi is going to be equal to 1. Right? Because the derivative of this with respect to Q2 is 1, derivative with respect to Q1 is 1. Okay? So when we're taking the derivative of this thing with respect to Qi, it's just the same as taking this thing with respect to Q. Okay? So the first thing we want is the derivative of this with respect to big Q. Okay, so that's just going to be minus beta Q to the minus beta minus 1. So x to the n goes to nx to the n minus 1. So, well, remember when we're doing products, we do derivative of the first thing times the second thing, plus the first thing, q to minus beta, times the derivative of the second thing. Okay, derivative of this is just 1. Okay, so that's our marginal revenue term, if you like.
We're not missing a K, can we?
Yeah.
Oh yeah, we're missing a K. Thank you. Happy? And then we're going to get minus Ci1. So this is the first order condition for firm I. Okay, for n firms, so for n copies of this first order condition. And what we always do is we just add them all together. So this gives, so when we add this first term together, you sure we didn't do this in the lecture?
We didn't do the first one.
Yeah.
Okay. They all seem
We've
the
done
same, don't they?
Yeah.
So when you add the n copies of this first term together, you know, here you get Q1, then you get Q2, then you get Q3, all the way up to Qn. So you get all of this times big Q. So K minus beta, Q minus beta minus 1 big Q. Okay. And then here there's no I here. Okay. So because there's no I, we just get n copies of it. So n, k, q to the minus beta. And then we get the sum of the marginal costs. Okay, so we're almost there at this point. Now we just simplified that. So let's take this minus beta to the front, minus beta k. We've got q to the minus beta minus 1 times q, well that's just the same as q to the minus beta. Okay, then we have n k q to the minus beta. So, what's this thing?
Price.
Yeah. So we can simplify a bit more. So this is minus beta times the price plus n times the price again minus the sum of marginal costs. So then we've added things together, we've done some simplification, now let's divide everywhere by n. Okay, so when we divide through by n, we're going to get naught is minus 1 over n beta p plus p minus average marginal cost. C1. Okay, so C1 is just defined as this thing divided by n. C1 with a bar in the top. Okay, so now we can rearrange. We've got a p here, we've got a p there. So in total we've got, let's put C1 onto the other side. So we've got C1 is equal to P times 1 minus beta over N. Okay, so P is C1 bar over 1 minus beta over N. Okay, does that make sense? Okay, so it's very similar to what we did for the linear demand case. We talked about that. Okay, so some of these further problems were about coordinates. So let's see how many we can do. 2.6, question 1 to 4. No, it won't be those. Actually, some of these maybe it is worth doing. What?
These are questions from the previous set.
Yeah, because we didn't do all of them, because some of them were on corner. And so we're a week behind with those, but we'll catch up. Are there any of these that people would particularly like to look at? Maybe we don't really have time to go through everything, so let's. So 6.8.
This one?
So this is a question about coordinate. See my fingernails.
Yeah.
But really this is just a special case with linear demand. Do we need to go through this? Do you want to see it? So you like to see it? Okay. So we saw linear demand with n firms, but sometimes seeing things with n firms can be a bit confusing, so maybe it is nice to see it with just 2 firms, just to remind yourself. Okay. You're going to be so bored of these porno problems. Okay, so the problem has price equal to alpha minus q. Firms have constant marginal cost of C1 and C2 respectively. Okay, everything else is fine. Okay, so profits for firm 1, it's really just the same thing over and over again. Profits for firm 1 are for price, so alpha minus q, times the quantity produced by firm 1, which is little q, minus the total cost for firm 1, okay, which is C1 times little q1, where constant marginal cost is C1. So, first order condition, pi1 dq1. That's an alpha, that's a capital Q, that's a little bit. Sorry, my writing is terrible. So, again, use the product rule to differentiate this, and you remember that the derivative of big Q with respect to little q is 1. So taking derivative with respect to little q is just the same as taking derivative with respect to big Q. Okay, so this is derivative of this thing, which is minus 1 times q1 plus this thing, alpha minus q, derivative of q1, which is just 1, okay, minus c1. So this is the first order condition for firm 1. You have an identical problem for firm 2. Profits for firm 2 were this thing, and the first order condition is going to be exactly the same, so minus 1 times q2 plus alpha minus capital Q minus c2. So you have your 2 first order conditions. Next thing you do is you add them together. Okay, so naught is equal to, we've got minus q1 here, minus q2 there, so that's minus capital Q. And then we've got 2 copies of the alpha minus q bit, and then we've got minus c1 plus c2. So you always get an expression of the same form. You get the price coming back here, you get the sum of marginal costs coming in here. Okay, and then we just need to solve this for quantity. So we've got minus q, we've got minus 2q. Okay, so in total we've got 3q, minus 3q. So 3q is equal to everything else. So 2 alpha minus c1 plus c2. So q is equal to 2 alpha minus c1 plus c2 all over 3. So that's total quantity, but you might want to know the quantity produced by a particular firm. But if you know total quantity and you know the first order condition, then it's very easy to work out the quantity produced by a particular firm. Okay, so we know what total quantity is, so we can just work out what Q1 is. So we've got a minus Q1 here, so put Q1 on the other side. We know that Q1 is equal to alpha minus Q, big Q minus C1. Okay, and we've already worked out what big Q is down here. So if we substitute in alpha minus Q minus C1, so just substitute in, you get alpha minus 2 alpha minus C1 minus C2 over 3 minus C1. Okay, and then we can simplify that a bit. So we've got We've got alpha here, we've got minus 2/3 alpha. So alpha minus 2/3 alpha is 1/3 alpha. So there's 1/3 alpha. We've got minus makes it plus. Okay, so we've got plus 1/3 C1 minus C1. So in total we've got minus 2/3. Minus plus 1/3 minus 3/3 gives minus 2/3. Minus, so this is a plus, so this is plus 1/3 C1 minus a whole. Okay, 1/3 minus 1 is. So this is minus 2 C1. Okay, and then we've got minus, so plus C2. And there's quantity for firm 1. And you can do the same thing with the first order condition for firm 2 to work out what Q2 is. Okay, some people are looking bored, so I should. So they're not too hard. You happy? Yeah. Good. So this was a question about entry with Cournot. So here, if you like, F is a cost, kind of a cost to produce anything at all. So it's like an entry cost. So there's a fixed bit of a cost and a marginal cost, but increasing marginal cost. So okay, so let's just go tackle B directly. Let me write down this problem. Does someone else want to have a go at this? You're all looking bored, so maybe you should get used to this sometime. You want to volunteer? Okay. So what have we got? So the price here is 100 minus Q. Okay, and the cost function C is F plus Q squared. Okay, so again it's a linear demand problem, but we don't have linear costs, okay, which makes it a bit more exciting, I suppose. So profit of firm I, 100 minus, so price times quantity produced by firm I minus firm I's total cost, so minus F minus QI squared. So the first order condition, d pi I dqi, well that's going to be, again, the derivative of this bit is going to give us a minus 1 times qi plus this bit, 100 minus q times derivative of this bit, which is just a 1. Derivative of constant is 0, so minus 2qi from the marginal cost bit. So this is for one firm. It holds for all I, we can add them all together just as normal, so we get minus capital Q plus n copies of 100 minus capital Q minus 2 times capital Q. So now we've got plus 1 minus 3. No. Yeah, so let's collect all the Q's together. So we've got and minus, isn't it? So I'll put them on the other side. So we've got 1 here, we've got n here, 1 plus n, and then we've got 2 there. Okay, so 1 plus 2 is 3. 3 plus n times q, and then what's left to go on the right hand side? Well, it's just that bit, isn't it? So 100n. Okay. So capital Q is 100n over 3 plus n. The terms are symmetric. Have I made a mistake? No? Don't think so. So the terms are symmetric. So capital Q is this. What's little q for all firms? Go on.
Q1 are all the same, so Q1
Yeah.
equals Q. So Q1 equals Q2, so
Yeah. Okay. So as a function, so how does it relate to big Q?
Q n times 1, and Q1 times n.
Is big Q. Yeah. Okay. So Q1 times n is big Q. That's what you're saying. So big Q is so little q1 is big Q divided by n, right? Okay, so qi for any I is 100 divided by 3 plus n. So 100, this is 100n, so we can just get rid of the n. So we know the quantity produced by each firm, we know the total quantity. What's the price? Well, the price is 100 minus the total quantity. Okay, so that's 100 minus 100n over 3 plus n. So if you like, that's 300 plus 300n divided by 3 plus n minus 100n divided by 3 plus n. Sorry, you can't see that, can you? So let's work, all I've done is rewritten 100 in a different way. So 100 is, if you look at this fraction, this is 300 plus 300 times n. So you can think of that as 100 times 3 plus n, all divided by 3 plus n. So this thing is just 100. So just rewritten 100 in a different way. Okay, so now we can simplify that. So that's 300 plus 200 n divided by 3 plus n. So we know price, we know the quantity produced by each firm. Okay, so we can go back and work out what profits were.
Was it 300?
Oh, have I made a mistake?
300 plus 100.
Yes. Yeah, thank you. Sorry. So this is 100 and yeah. Okay, so I knew it's simplified. Okay, so we've got 100n, we've got minus 100n, so they cancel. So this is 300 over 3 plus n the price. Okay, so the profit, let me get my sheet of paper. So at the start we had this expression for profit, so pi I was 100 minus q times qi minus f minus qi squared. Okay, so all you have to do is just plug in at this point. So 100 minus q is just the price, we've already worked that out. It's 300 over 3 plus n. All times qi, which we worked out was 100 over 3 plus n, minus f minus qi squared, okay, which is going to be 100 over 3 plus n all squared. So we can simplify a bit, right? So this is, let's just do it in multiple steps. So this is 3 times 100 over 3 plus n all squared. So all I've done is realise that 300 is 3 times 100. So then you can take the 3 outside of a bracket. What you're left with is 100 over 3 plus n times 100 over 3 plus n. Okay, so 100 over 3% squared. So we've got 3 times this minus 1 times that. So that's 2 times 100 over 3 plus n all squared minus f. Okay, and firms are going to enter up to the point at which profits are approximately 0. Okay, if profits were strictly positive, more firms would enter. If profits were negative, firms would leave. So when with free entry, pi I equals 0. Okay, so this thing is 0. So 2 times 100 over 3 plus n all squared minus f is 0. So adding f to both sides, f is equal to this thing, 2 times 100 over 3 plus n all squared. Okay, so divide by 2 and then take the square root. So the square root of f over 2 is equal to 100 over 3 plus n. I know it's a quadratic. Quadratics always have 2 solutions. The other solution would have negative n, which clearly doesn't make sense. Okay, so we can safely ignore the other solution. And then, well, we can invert both sides. So root 2 over f is going to be 3 plus n over 100. So n is equal to 100 times root 2 over f minus 3. So that's our number of firms. So we now know how many firms would enter in this world. And that all makes sense. There's quite a lot of steps, but each individual step is quite easy, right? It's not. Don't think it's really difficult. Do you want me to go over any of that? Is everyone speaking? It's fine if you. No? Okay. Well, I assume you're happy. Okay, we might come back to the extra exercises from last week if we have time at the end. Well, we had some written exercises in these slides, remember?
Yeah.
Was one before this? Is that the first one? Yep. Okay, so this is useful because it's useful starting to think about welfare in terms of integrals rather than just drawing pictures. Okay, so in the lecture we went through this expression for welfare, for the deadweight loss. And this question was asking you to simplify it when you have linear demand. So we're going to find out what the deadweight loss due to monopoly is with linear demand. Okay. So let me just write what we have. So we've got the price is P0 minus P1 times Q. And the first thing we need to, what's marginal cost? So marginal cost is constant at C. First thing we're going to need to work out is what the monopoly quantity is, the monopoly price, and what the perfect competition price and quantity is. So let's do perfect competition first because it's easy. So under perfect competition, what's the quantity? How do you find the quantity?
Price equals cost.
Yeah, okay. So cost is C. So C is P naught minus P1Q. Okay, so what are we going for? So P1Q is equal to P naught minus C. So Q is equal to P naught minus C over P1. So let's call this QPC for the slide. So this is quantity produced under perfect competition. So that's easy. And we also need a quantity produced under monopoly. So the monopolist is going to maximize price times quantity, so P naught minus P1 Q times quantity minus their cost, which is C times Q. So first order condition. So just as ever, you're going to use the product rule. Okay, so you get minus P1. It's always exactly the same. That's P naught minus P1 Q minus C. Okay, we're just using the product rule again here. And then we're going to collect all the Q's together. So we've got minus P1Q, we've got minus P1Q. Okay, so we've got two copies of minus P1Q. So 2 P1Q is equal to P naught minus C. So Q is equal to P naught minus C over 2P1. Okay, so let's call this Q N for monopoly. And what you see is that the monopoly quantity is half the perfect competition quantity. Okay, it's a general result with linear demand. So this is stuff that you saw before in the first lecture. So now we're asked to find out the deadweight loss due to monopoly. Okay, and remember in the lecture we talked about the deadweight loss being equal to this integral. You look at quantities between the quantity produced under monopoly and the quantity produced under perfect competition, and you're taking the area between the demand curve and the marginal cost line. Okay, so in terms of a diagram, here's price, here's quantity, there's the demand curve, here's marginal cost. The monopolist is producing, so this is quantity under perfect competition, that one. Monopolist produces some, you can't see, can you? Monopolist produces some smaller quantity here, say. So because they produce a smaller quantity, the monopolist gets some producer surplus, the consumer still gets some consumer surplus, but there's this extra triangle of deadweight loss. Okay, so it's that triangle that we're interested in. So what's that triangle? Well, this is quantity under monopoly, this is quantity under perfect competition, so it's the integral from quantities between those two extremes, okay? And it's the difference between the demand curve, P of Q, minus the cost line. Okay, so let's just substitute in what the demand curve is. So the demand curve was P naught minus P1Q, okay, minus P1Q. So, do we remember how to integrate? It's a long time ago, integration. You know, to be honest, in practice, if you got a question that asks you to calculate welfare, you'd normally be able to do it by just looking at the picture and working out the area of the triangle. Okay, so let's do it. Let's do it the lazy approach first, okay, and then we go back to the slightly more rigorous one. So, you know, if this is our triangle, this is quantity under monopoly, this is quantity under perfect competition, and these are the prices under perfect competition and monopoly, right? So what's the area of that triangle? Well, it's half times QPC minus QM times price under perfect competition minus price under monopoly. Have we got this wrong way around? Yeah. Sorry. Quantity under monopoly minus quantity under perfect competition. No,
that part prices.
The prices.
I give up. Well, what if you come and do this? That's not doing too much. Okay. QPC. So quantity is higher under perfect competition, so it makes sense that's first. But then price is higher under monopoly. Price under monopoly minus price under perfect competition. Okay, so with linear demand, because it's just a nice triangle, the dead weight loss, we know that the area of the triangle is half base times height, so we know that dead weight loss is going to be that area. Okay, and then all we'd have to do is substitute it. So QPC, well, remember we said that QM was half of QPC, so QPC minus QM is just QM. So this is half QM star, and then the prices, so the price under monopoly is P0 minus P1 QM star, and the price under perfect competition is just C. Okay, so let's substitute in for what QM star is. So this is half times P0 minus C over 2P1. P0 minus P1. Okay, so can we simplify this? I guess some of you have done this question, so maybe you can help me out. Oh yeah, so look, we've got a P1 there and a P1 there. So these two things are going to cancel, and then we're going to get something that looks a bit nicer. So let's do it in multiple steps. So we'll do that first. P0 minus C over 2P1. Okay, so then you get, so these are cancelling. And then we're just going to multiply out the bracket. So we've got P0 minus, here we get a half P0. Minus minus makes a plus. Okay, so we're going to get plus half C. And then we're going to get a minus C. And now we can simplify that more. So this is P0 minus C over 2P1. So this is P0 minus half P0, which is half P0, half C minus C, which is minus half C. So this is P0 minus C over 2. So we've got P0 minus C, P0 minus C. So this is, and then on the bottom we've got 2, 4, 8 and a P1. Okay, so this is going to be 1 over 8 P1 all times P0 minus C squared. So does this make sense? So if marginal costs are high, then dead weight loss is smaller. That makes sense. Yeah, if marginal cost goes up, then the area of that triangle must be shrinking. Is everything okay? You know, and in the extreme case in which so is price quantity is our demand curve. Think about so if the demand curve crosses here at P0, in the extreme case in which C is P0 or higher, then marginal cost line's up there. Under perfect competition, nothing is produced. Under monopoly, nothing is produced. Okay, so it makes sense that when C is high, deadweight loss should disappear, because with high C, the two things are giving you the same answer. Increasing P0 is increasing the amount of demand, if you like. And more demand is also leading to a bigger deadweight loss, that makes sense. But it's decreasing in P1, which is a measure of a slope of the demand curve. So if the demand is very, it's very steeply sloped, then, I guess it makes sense if the triangle is quite a small area. And if P1 is very small, then the demand is almost flat, it's almost completely inelastic. And then the monopolist wants to set an incredibly high price. With perfectly inelastic demand, the monopolist sets an infinite price, so you get a bigger and bigger distortion. Okay, so that seems to make sense. So this was the way of doing it based on looking at the picture. Let's just go through the first step of how you do it if you're going to do it based on integration. Okay. So we had this integral, and the way you evaluate these definite integrals is you evaluate the indefinite integral at the top and then subtract the indefinite integral at the bottom. Okay, you remember this. And people often use this notation with square brackets. So they often use square brackets, something, Q, with the limits written on the side of the square brackets. So let's just work out what the indefinite integral is. So the indefinite integral of P0 is just a constant. So the area under a straight line is like a box, right? So the indefinite integral of P0 is P0 times Q. What's the indefinite integral of this thing? P1 times Q?
P1Q squared over Q.
Yeah, exactly. So, the area under y is x. Well, what's that? It's just a triangle. Okay, so this is x, so this is half x squared. Okay, so this is our half P1 Q squared. Minus c is just a constant again, so minus cq. So this is our indefinite integral. We evaluate the indefinite integral at the top, we subtract the value from evaluating it at the bottom, you'll get the same answer, but I won't get through this. Were there any other exercises I wanted to go through? I don't think we had any other in the lectures. So we had these two. So this one is very similar to the one we just looked at from the book, right? Let's see how fast we can go through it. Okay, so exercise says Q is 1 minus P, entry, so 0 marginal cost, C is 0, and there's some entry cost of F. Okay. So in the second stage game, we kind of forget about the entry cost. So let's solve it in 2 stages. So we solve once firms have entered, what profits do they make, and then we'll work out how many firms entered later. So in the second stage game, firm I is going to make a profit of 1 minus P times Q. Oh, sorry. So here I gave you the demand curve. The first thing we need to do is work out the inverse demand curve. So what's the inverse demand curve there?
P with a 1 minus Q.
Yeah, exactly. So here's our inverse demand curve. That's where we start from. So profits are price times, so price is 1 minus big Q times quantity, which is little q. There's no marginal cost. So there's profits. What's first order condition? d pi I dqi. Well, again, the derivative of big Q with respect to little q is just 1. Okay, so this is minus 1 times qi plus 1 minus q. Add them all together. Are you bored of adding them all together yet? So minus big Q plus n times 1 minus big Q. Okay. So we've got n plus 1 big Q is equal to n. So Q is equal to n over n plus 1. Right. Okay, so big Q is n over n plus 1. What's little q? Yeah, thank you. So little q is 1 over n plus 1, and the price is going to be 1 minus big Q, so price is 1 minus big Q, which is 1 minus n over n plus 1. Okay, so you can think of 1 as n plus 1 divided by n plus 1, so it's minus n over n plus 1. Okay, so what's that equal to? N and n cancel out. So
1 over equals 1.
yeah, exactly. 1 over n plus 1. So we rewrote 1 as n plus 1 over n plus 1. So then we had n and n cancelled, so we're just left with 1 over n plus 1. So we know everything at this point. We know the price, we know the total quantity, we know the quantity produced by a particular firm. So the profits of a particular firm are the price, which is 1 over n plus 1, times the quantity it produces, which is also 1 over n plus 1. Okay, so 1 over n plus 1 squared. Have I made a mistake?
I know, I was just wondering in that bit, like, what did you do to the fixed costs? Did we just forget them?
So we're so you can treat, so we're thinking of it as a two-stage game, and this is profits from the second stage. It's not total profits; it's kind of gross profits, if you like. Yeah. So this is profits. Pi I is profits from the second stage once firms have entered, and now we're going to work out how many firms would enter in the first stage. Okay. So in the first stage, firms pay this entry cost of F. They know that in the next period they're going to get the profits of 1 over n plus 1 squared. And
Sorry, I think you're sleepy.
it's fine. I'm quite sleepy. So the equilibrium condition is that the fixed cost should be equal to the post-entry profits. Okay, so F is equal to pi I. It's fine, not off again. I'm bullish. So this is the profits they make once they've entered. Okay, so firms are going to carry on entering until the marginal entrant would make no profits. Okay, so the condition is that F must be equal to that thing. So the square root of 1 over F must be equal to n plus 1. I've just inverted both sides and taken square roots. Okay, so n is equal to root 1 over F minus 1. Is that the answer you got? Yeah? Yeah. It's all too easy for you, though. We can do it. Then there was this exercise. So just a slightly funny demand curve. So this one has Q is 1 minus P and 0 marginal cost. Okay, so we want to invert the demand curve again. So the square root of Q is equal to 1 minus P. So P is equal to 1 minus square root. Okay, so that's the demand curve. Then profits are price times quantity minus marginal total cost, but total cost is 0. Okay, first order condition again. Yeah, so again you're going to use the product rule on this thing. So the derivative of square root of Q, I think you were right to start with. So it's x. So square root of Q is, that's Q to the half, right? So it's half Q to the minus a half, okay, or half Q 1 over root Q. Okay, so this is half 1 over root Q times Qi plus 1 minus root Q. Okay, it's a bit more messy than previous ones we've had, but again, you just do the same thing. So this is for firm I, it holds for all firms, so you can add all of them together. So this is half 1 over root Q times big Q plus 1 minus root Q. Oh, sorry, n copies of that.
Are they minus the halves?
Oh, because of that, yeah, sorry. Sorry about that. And let's just simplify this a little bit. So we've got Q divided by square root Q, or Q is square root Q times square root Q. So Q divided by square root Q is just square root Q. So this is minus a half square root Q plus n times 1 minus square root Q. So now we have an expression in square root Q. So let's solve for square root Q. So we've got, in total we've got a half plus n copies of square root Q, and that has to be equal to n. Okay, so square root Q is equal to n over half plus n. So Q is equal to the square root of n over n plus half. Yeah, as we're running out of time, I'll leave it at that. Okay, the question asks you to find the number of firms. But
The last line you need to square it.
Not square root
root it.
yes. Just checking you're paying attention. Okay, thank you. Thank you. N over half plus n squared. Isn't it gratifying to see that I make these mistakes as well? Yeah, it's the kind of mistake that I see a lot in exam answers. So the question asks for an expression for the number of firms. Okay, we won't go through it, but you know what you do. You know what big Q is, so you can work out what little q is, so you can work out what profits are, equate profits to the entry cost. So, okay, it'll be slightly messy. And last thing we'll look at is this 6.8 question 2. I don't know what it's like. Oh, we did that already. We just did that.
Yeah.
Oh, okay. Well, then I thought we had another exercise to go through. We can. You can either go, or I can go through the rest of this. Votes for going through the rest of this? Yeah. Okay. Well, we'll go through it. So that's what big Q is. So what's little q going to be?
You just hit me.
Yeah, so we've got an n squared on the top, so we'll just be left with an n on the top. So n over half plus n all squared. Okay. So there's our little q. And the other thing we need is for price. Okay, so the price is equal to 1 minus square root of q. And we know that square root of q, we found an expression for square root of q before, right? This one. The square root of q is n over half plus n. So the price is 1 minus n over half plus n. Okay, so this is half plus n over half plus n minus n over half plus n. So we've just rewritten 1 as of this fraction. So we've got n here, we've got n there, they cancel. So that gives us half over half plus n. Makes sense, I think so.
What's happened on the side of this?
Pardon?
What's happened on the other side?
What? Oh yeah, yeah. No, I'm just thinking, because remember we've got this restriction that p has to be less than 1. So if you think about what this looks like, when p goes beyond 1, it starts increasing again. So I was just thinking whether our price was going to be less than 1. Okay, so we know our price, we know the quantity. So the profits are price times quantity. So it's half over half plus n times quantity, which is n over half plus n all squared. Okay, so we've got half plus n here, half plus n there. So in total we've got 3 copies of half plus n. Okay, so this is half n over half plus n all cubed. Okay, in equilibrium, firms enter until the profits from entering is equal, the cost of entering is equal to the profits you get once you've entered. So this has to be equal to the fixed cost. It's not very nice, is it? So 1 over f, well, so half n is equal to f times half plus n cubed. Really, did I say this exercise? Doesn't seem very nice, does it? One second, sorry. So look at profits. No, it's fine. So does someone from the audience want to volunteer? Did you get past this point? It's not very nice, is it? I think this might.
Plug in fresh. Plug in and refresh.
You're confused? At what point did you get confused?
Sorry, I missed the last lecture, so I'm
Okay.
just really confused.
Come up with that to me later, maybe. Yeah. Well, so I think I don't know. I think I was being a bit over ambitious with this question. So I say an expression for the number of firms. So here's an expression for the number of firms. The number of firms is the solution to that equation. You know, you can multiply out these brackets, and maybe I've constructed it so that it does have a nice solution, but
For the one before, with the linear demand, where have you calculated social welfare? The welfare optional?
oh, okay. No, that's a good question. Let's. So the question was, what piece of paper is it? So this one we worked out the number of firms that enter as being this expression. The question asked for the social welfare and the welfare optimal number of firms. Okay, so if we think about social welfare in this world, so the demand was 1 minus P, so we know that's a 45-degree line, for 0 marginal costs, okay, so social welfare is the area of this trapezium. Okay, some of it's consumer surplus, some of it's producer surplus. So this is the quantity produced, that's social welfare. So the area of the trapezium, as you remember from your high school maths, is this distance times the average of these two distances. Okay. You can do it as a square plus a triangle if you like. What?
Integrate.
Or you can integrate it. Yeah.
Which is not so easy. You just don't take anything away.
Okay. So this is Q is the base, and then we're having the average of the other two distances. So this distance is 1, and this distance is 1 minus Q. So it's 1 plus 1 minus Q all divided by 2. Okay, so this is Q times 2 minus Q. What's wrong? No, sorry. So there's our social welfare as a function of quantity. So we know the optimal quantity that gets produced. Okay, so Q was equal to n over n plus 1. And n was equal to this root 1 over f minus 1, I think. So this is root 1 over f minus 1 over root 1 over f. So that's quantity as a function of the entry cost. And you can simplify this a bit. If you times top and bottom of this fraction by square root f, so this thing times square root f is just 1. 1 times square root f is square root f, and the thing on the bottom times square root f is. So this is just 1 minus square root f. So does this make sense? If the fixed cost is small, so if the fixed cost is 0, then infinitely many firms enter. You know, there's nothing stopping firms entering, so you get Q is 1, you get the perfect competition quantity. If the fixed cost is 1, then nothing gets produced at all. That makes sense. So this is the quantity that gets produced. When the market is left to decide how many firms enter. So to work out social welfare, we just plug that into that. So this is, let's call that W. So welfare is 1 minus root f times 2 minus root f over 2. upper brackets. So we get 1 times 1, which is 1, you get minus root f.
Shouldn't that be 3?
Oh, have I made a mistake?
1 minus root f.
Yeah.
So,
So the brackets you've not added the ones
in the second bracket.
2 minus
Yeah,
1.
2 minus q over. Yeah. So welfare, first bracket was fine.
The second bracket
Yeah,
just needs to
was
take
1 minus root f. Okay, and then I'm doing, so 2 minus something divided by 2, and the something is 1 minus root f.
so it being 1 plus root f.
Okay, so 2 minus 1 is 1 minus minus, yeah. So it's half times 1 minus root f times 1 plus root f. Happy? So 1 minus root f times 1 plus root f is 1 minus f, isn't it? Half times 1 minus f. Because you get a minus root, when you multiply out these brackets, you get a 1, you get a minus root f, you get a plus root f, and then you get a minus f. So welfare, it's a very nice expression for welfare. Welfare is half times 1 minus f, so the higher the fixed cost, the lower welfare. Oh no, there's one other thing we've forgotten. This is for welfare ignoring the fixed cost. So this is for welfare from the production stage. Just as before we were looking at profits from the production stage, this error is welfare from the production stage. Okay, but the fixed cost is also fanciful welfare. So the total welfare, if you like, total W is half 1 minus f minus n times f. Okay, n copies of the fixed cost being paid. And what is n? Well, n was on one of these pieces of paper. This one, was it? 1 over root f minus 1. 1 minus f. This stuff with welfare and Corno was what we'll be looking at this in next week's lecture. So really, this is kind of next week's lecture because we didn't get as far as welfare and Corno in the last week's lecture. So because we're already late, let's leave the optimal number of firms till the next class because we're going to be looking at the optimal number of firms in Corno next week.